dimensions that new technology has allowed us to explore, there's one that's straight out of science fiction. A black hole.
Everything that we're familiar with in ordinary life is made from matter, but not black holes. Black holes are made from warped space and time, and nothing else.
There's a black hole, guys.
A black hole is an object that is spherical, like a star or like the Earth, with a sharp boundary called the horizon, through which nothing can come out. So it casts a shadow on whatever is behind it. It's just a black, black shadow, unbelievably black.
This simulation shows the distortion of starlight around a black hole. Even though Einstein knew his theory predicted black holes, he found it hard to believe they would really exist in nature. In the 1960s, Professor Kip Thorne worked on the mathematical concept of black holes. The idea made sense on paper, and he began to feel that these science fiction-like objects might actually be real.
It must be here somewhere. It's in one of these piles.
Kip Thorne made a bet with fellow physicist Stephen Hawking about whether or not a strong source of X-rays, known as Cygnus X1, was in fact a black hole.
I think it's in here. Yeah, here we go. Relative stars and black holes. Yeah, there it is. So that is a copy of the famous bet. Stephen Hawking bets 1-year subscription to Penthouse magazine is against Kip Thorne's wager of a 4-year subscription to a political magazine called Private Eye, that Cygnus X1 does not contain a black hole of mass above the Chandrasekhar limit. It's witnessed this 10th day of December 1974. Stephen Hawking had a terribly deep investment in it actually being a black hole. And so he made the bet against himself as an insurance policy that at least he would get something out of it if Cygnus X1 turned out not to be a black hole. Now, the evidence mounted thereafter over the period of the 70s and 80s. And in June 1990, Stephen snuck into my office and signed off on the bet that finally the evidence was absolutely overwhelming that Cygnus X1 really is a black hole. And Penthouse magazine arrived. He sent me the British version of Penthouse, which was ever so much more raunchy than the American Penthouse. Actually, enough to make my face turn red when I received it at first.
I was born in 1988, motherfucker.
Today, we have evidence suggesting that there are millions of black holes in our galaxy alone. But perhaps the most profound prediction of general relativity is that our universe had a hot, dense beginning that we call the Big Bang. The discovery that distant galaxies are moving away from us, and that there's a background radiation permeating space, provided evidence for the Big Bang and a universe that's growing.
With this picture of the expanding universe, there is natural questions. Is the universe slowing down as it expands? Is it so dense that someday it'll come to a halt and collapse? Will the universe come to an end? These seem like good questions.
To find answers, in the 1990s, Saul Perlmutter and his team observed exploding stars called supernovae to track the growth of the universe.
They were called supernovas.
When we made the measurements, we discovered that the universe isn't slowing down enough to come to a halt. In fact, it's not slowing at all. It's speeding up. The universe is expanding faster and faster.
Whoa!
But what's pushing it?
In order to explain the acceleration of the universe within Einstein's theory of general relativity, we're considering a energy spread throughout all of space that we've never seen before. We don't know what it is. We call it dark energy. And if so, it would require something like 70% of all the stuff of the universe to be in this form of previously unknown dark energy. So this is a lot to swallow. And you might imagine that at that point you should go back and revisit your theory. The problem is that Einstein's theory is so elegant, and it predicts many, many, many digits of precision that it's very, very difficult to come up with any other theory.
The theory of the universe.
There is one final prediction of general relativity that remains untested.
Extraterrestrial.
Gravitational waves.
There are huge things in the universe happening, like black holes colliding or stars exploding. Then they create these gravitational waves, the waves in the shape of space and time that travel through the universe at the speed of light. And so right now, the space around me is being squeezed and stretched by gravitational waves just getting here from, let's say, two black holes colliding 1 billion light years away. But the squeezing and stretching is so minute, I absolutely could not personally detect it. And so what we're trying to do is build an instrument that can.
She believes in extraterrestrial, guys.
In Louisiana and Washington state, a vast experiment called LIGO is in the final phases of calibration. It's hoped that laser beams traveling 2.5 miles between precisely aligned mirrors will measure the squeezing of space caused by gravitational waves. This could open up an entirely new window on the universe. For 100 years, general relativity has been proven to be correct time and time again. But Einstein himself knew that his great theory had limits. It remains incompatible with the quantum world of tiny atomic particles. Here at the Institute for Advanced Study, where Einstein worked, the world's leading theoretical physicists are trying to solve the problem Einstein never could. Finding a single set of rules that applies to both the cosmic and atomic scales. A unifying theory, the holy grail of physics.
We are now in what at this time is the School of Physics. So here people are still struggling with many of the same issues that Einstein was struggled and are still trying to capture the laws of the universe from the very small to the very large in a single equation. And it's still blackboards that are the weapon of choice. The brightest minds of the world are coming here to work 24 hours, 7 days a week, struggling to grasp the great mysteries of the universe. And I think we're still driven by the same dream, that at some point we can capture everything in elegant mathematics.
100 years after Einstein transformed our understanding of nature, the stage is set for the next revolution.
When we finally move beyond Einstein, it might be another singular genius that comes along, someone struggling in a poor school in Kenya right now that we don't know about, or it might be 20 different people with 20 different points of view gradually building brick by brick to finally figure out a more comprehensive view that includes general relativity in it.
Okay.
I think the most important thing that you learn from Einstein is just the power of an idea. If it's correct, it's unstoppable. It's extremely encouraging that he was able, with pure thought, to solve the riddle of the universe.
Once we had general relativity, the world changed completely. Our point of view on the world changed completely.
She's not.
I mean, the origin of the universe is a prediction straight out of general relativity. We didn't have that before.
I often wonder what Einstein would make of today's theoretical physics. And I think he would really be saying, get on with it, get the right story, get the details right.
You have the huge universe, and it obeys certain laws of nature, but where in the universe are these laws actually discovered? Where are they studied? And then you go to this tiny planet, and there's this one individual, Einstein, who captures it. But now there's a small group of people walking in his footsteps and trying to push it further.
And I often feel, well, you know, this is a small part of the universe that actually is reflecting upon itself, that tries to understand itself.
Hope you guys enjoyed that. Boy, just got a Supreme Life. I was trying to keep you notified on cool shit. So I thought that was cool. I liked it. I just hope you guys liked it too. We hyped it today. Every single day. Like and subscribe to the channel. Smash that subscribe button. Smash that like button if you like this. It is your boy Juice God 8 Supreme Life. Supreme. Everybody, you ain't lit, you ain't shit. It's every single day, bro. It's every day, bro. With the Juice God flow. Heck yeah. So we gonna get it. Do all that. I'll see y'all later. You know what it is. Della Roma. Bellissimo. See you tomorrow. Yeah.